Hey everyone, and welcome back to a new episode of the Information Bottleneck. Hey Ellen.
It's good to see you again, Ravid. And the first episode in maybe six or plus where it's just us two again, because we heard from some of our viewers that they wanted us, when we bring more, guests onto the show, to have the guests spend the entire time talking about their research. And we agree, the Twitter drama and the news is something that Ravid and I can handle ourselves. So we'll do that
Yeah,
from
and now like we have one more hour to talk about anything that we want, right? Yeah, so maybe let's start with some recent AI news. Inception Labs, they did a new model, all model Mercury model. They just raised $50 million, and it's really cool. I must say that. So the Mercury model is a diffusion based model that is really fast for fast coding, and I must say that compared to other big industry labs or like big industry lab startups that raise a lot of money and don't know what they are actually going to do, they have very vague ideas. I'm really bullish on Inception Labs, mostly because Stefano Ermon. If you don't know who is like a professor at Stanford, super smart, very productive. They have so many papers in the recent years and such great ideas, matching flow, diffusion models, a lot of different ideas in directions. I really like him. I almost did a postdoc with him. He was like my second option after Jan, so he's really great. But besides him, I think that like the idea that a professor takes an existing idea or direction that they already explored, and now they're taking this and trying to make a product, I think this is the right direction. And I think this is a very good path, let's say, compared to, we have very vague idea, we are really smart, we will figure it out. I think this is much better, and you can see, right? Like they have these ideas and they implement them, and now they have really good, really fast coding model.
So I've looked at this, and I guess the very first thing is, I work on LLM sampling, and have even got your name on some of those papers, Ravid, and you've done extensive help. I think that LLM, diffusion models force us to rewrite everything we know about sampling. So like top P, top K, even temperature, no longer a thing in the same way. And that's hard for me to swallow personally, right? So it will take time for me to kind of move. And I'm aware of how like diffusion models have, denoising algorithms, but I'm not sure how this is going to work at all with, denoising LLMs. The second thing I'll say is, right at this moment, Mercury's pricing is still like $1 for 1 million tokens output. And so, yeah, the model's extremely fast, but I don't know if customers will be okay with the quality for what they have to pay when they compare to not a lot more money to get Google Gemini, right? So in that sense, I worry that they fall into the same problem that everybody else who doesn't have $2+ billion does, of AI being winner take most. But you're right. I mean, when people look for and complain about, hey, we way over indexed on the transformer and basically LLMs as everybody else designed them, this is a company that's truly doing it differently. So I applaud them.
Yeah, and I must say that discrete diffusion is not so complicated. At the end, it's just like masking in iterative rate, if you want, right? So it's not very different, like conceptually, than I know, like BERT and all these models. So I don't think it's really changed all the things that we are thinking about sampling. I think you still need sampling. You probably want like to tweak these samplers a bit, but I think it can be also very, very relevant tool for diffusion models. By the way, if you want to make samplers for diffusion models, you can email us. Like maybe we can do something together.
Yeah, we'd love some assistance on that. I'm also
Yeah.
curious then, because I'm glad you mentioned the similarity to BERT, and before BERT came out, and then there was GPT-2, and the big difference between them at the time was, were you doing CLM, casual language modeling, meaning, autoregressive next token prediction like we all do today, or were you doing masked language modeling, which meant Mad Libs, right? Which meant that you could delete, something and have forward and backward context, hence the bidirectional in BERT, right? The B in BERT. Now, that also means that you can take a text where you've written the forward and afterward and have it intervene in the middle, where getting that behavior from ChatGPT is actually not straightforward because of its, even when you're in developer tools, right? Giving it the context and asking it to write in the middle instead of at the end of its context. I don't even know if that's possible. And if it is, it's with hacks. So I actually find that there's a massive improvement in creativity potential with these kind of new models. I'm also bullish on Inception. I just really hope that they can get the money they need to prove Mercury with scaling up its quality of data, training, and compute and everything.
Yeah, at the end, it's not clear that even 50 million is enough. Right? Like 50 million is a lot of money. For sure, this is something like we didn't see before. Like we didn't see a company with that I don't know or seed raise so much money. But still, it's not clear that this is enough to make this scaling up their models and to actually make it something that people will use. And as you said, like they want something real, like the users at the end want something very, very good. Like they don't care almost about whatever the specific algorithm, like the specific cost or time. They want something good. So it's an open question if you can do it with 50 million.
Yeah. Yeah, and it's sad too that we're so excited about a relatively small amount of money. I say relatively because, back in 2021, basically at the end of the zero interest rate era, they would have added another zero to that number probably. So, and that additional zero would really help Inception.
For all of us. It can help all of us. Okay. What about the Apple deal with Google? Did you hear they're going to pay $1 billion annually to use Google Gemini for their new Siri? Do you
Yeah.
think
What were you going to say? Sorry.
so? Yeah, so I want to say, okay, from one end, like this is, I don't know, it's not a lot of money, right, for Apple, right? It probably, if it's a good model and if it actually can make people actually use Siri, it will be amazing. But from the other hand, I think it prevents them to develop their own tools and like their own model. I think this is the big problem at the end, right? Like, I don't think it's really complicated for Apple to make almost state-of-the-art models. We all know the recipes, or most of us know the recipes. Take a lot of researchers, take a lot of GPUs, use existing Chinese models or Chinese papers, and make your own model that will get. Maybe it will not be, the best thing that ever exists, but probably for Siri, it will be fine. So for the long term, I'm not sure this is the right decision, I must say.
Well, this really heavily goes with my thesis of AI being a winner take most phenomenon. I'm also this article, interestingly, maybe I'm way out how to, I didn't know if there was public data on the maximum size of like Gemini Pro, but here they're saying, oh, the custom AI model, which I assume is Gemini Pro, is 1.2 trillion parameters in comparison to the current cloud version of Siri, or the LLM powering the Siri LLM features, is only 150 billion parameters. And I know that the on-device one Apple's using is, I think, below 3 billion. And those parameter counts are just, for today's models, way too low for the quality that I think they want. I'm also intrigued by Apple deciding against OpenAI and Anthropic. I'll point out OpenAI has been rapidly, apparently, losing market share in the enterprise world, I think very heavily due to the model router and maybe due to concerns about like future, I don't know, maybe the tweets about erotica scared some people in regulated domains, but Anthropic and Google have been really coming up on that. And Google is probably the less censored of the two and less aligned, right? Anthropic is really the whole safety focused of them right now. I actually figured Apple would have signed with Anthropic, given all things being equal. And indeed, I have repeatedly told people whenever, it comes up, my goodness, Apple and Anthropic would be great bedfellows. Like, Apple should buy Anthropic. Like, I have straight up advocated for this repeatedly to help both of the firms. So the fact that that didn't happen is quite remarkable. But yeah, I'll just finalize by saying that Apple is an extremely secretive company. Famously, out of the Fang, they were, I mean, Netflix notwithstanding, right? Apple was the most secretive of them by far, and I think that that harms the kind of collaboration necessary to move so fast with AI and LLMs. I mean, the cult of openness around research and even code is a blessing for everybody who's developing with it. And when you have to kind of, due to internal corporate secrecy policies, get away from that, I think it harms Apple and makes them uniquely slow at developing like state-of-the-art language models. Also, I think that they don't have a domestic large quantity of like NVIDIA GPUs. Like, I don't believe that they would have had a reason to have like 1 million plus of them, whereas every other member of the Fang did, right? Facebook, due to the whole the social media having all the GPUs just needing to power the god dang it, what do you call it? The infinite feeds, right? And so I think that's kind of the reasoning, but it's very interesting. And it's still gonna take until next spring, right? Apparently, just to finish their fine-tuning, right?
Yeah.
And everything. So that's I don't know what to think about this, but it clearly shows that Apple's not gonna try to make their own LLM in the next 6 months.
Maybe, or maybe they will do something in parallel, right? Like, it doesn't mean that they're not going to try at least.
Yeah. Yeah.
Yeah. Okay. It looks that this week also the Alpha Arena season. The first season ended, right? So if you don't know, the Alpha Arena is a benchmark, is a leaderboard. They gave all the, I think, like 6, 7, 8 leading LLMs, leading models. They gave them, I think it was $10,000 to make investment. It can be high frequency, whatever you want. They take $10,000 and make it more. Try to make it more the best way that you can. And at some point it looked at, like, I think there were like the Chinese models were really good, and like people said, oh look, they are going to make so much money and control the world. Um, and at the end, it looks that most of the models were quite equal. Some of them lose a lot of money, some of them lose a small amount of money, but it doesn't look at the end. It doesn't look that any model was much better or like take a advantage in any aspect. And I saw a funny tweet that it was congrats to Llama 3 Large for winning the LLM trading contest but not participate. And I think at the end, this is it tells you something about our beliefs. Because if you ask a random person, or even, I don't know, Silicon Valley a founder or startup, now you give me like, if you will give to a model $10,000, can you make it more? Probably will say, we will try to, you start to hand wave and say, yeah, you can aggregate information and can understand and search like some internal I don't know, internal news and things like that, right? I can collect information from different sources, and then for sure he can break the market. And you can see it here. It doesn't work, right? And I think this is a great example to something that looks obvious to us, but in practice, LLMs are not going to do it better.
Yeah, wow. I have so many opinions about all this. The first is when you're trying to study any type of economic graph, where you decide to start and stop, how much you zoom in or zoom out, is an extremely important and ultimately subjective thing. Like, for example, depending on how you zoom in or zoom out of the SPY graph, you can make all sorts of conclusions about what you should or shouldn't invest in. And in particular, with gold's prices having shot up very recently, a lot of people, who had been parroting the line of, oh, SPY, if you'd invested in S&P 500 for over some large period of time, you come out better than investing in precious metals. Well, the recent gold, crazy going uptick made that not true, retroactively, this like statistic about 40-year thing. So that's just the first concern I have, especially pointing out how at the very end, Quen was able to make a comeback at the final stage of the championship. But we saw several moments, especially earlier on, where there was quite a bit of variation in switching who's at top and who's at the bottom. So that's its one problem, which is to say, like, where they ended was very arbitrarily chosen. And it could be that models, even the models that were already, losing some of the money, could have way shot up for reasons that would have been hard to predict. Another thing is all those intricacies, sampling settings, chat templates, prompts, and, even the time of day, the RAG mechanisms, if they're being used, the mechanisms for getting the actual stock prices. There's so much complexity with this that I could see models with changes just to small parts of those performing so radically differently. And you can't reproduce the exact moments of a market unless you're back testing away, right? So it's not like you can just go to a new point in reality and redo that all again, in a sense. And then finally, you're targeting, just like traditional, it looks like either crypto or traditional securities only. But here's an example of, and I feel bad for my friend who he keeps on whispering in my ear. I have a close friend who keeps on telling me, "Hey, Alan, there are these prediction markets where they try to predict on what words Jerome Powell is going to say during his federal minutes. Not even are they going to raise interest rates, but will he say the word like negative or something? And if so, how many times will he say it?" And so people bet on ridiculous things like that. And AI and LLMs, next token prediction, fine tuning on that is perfect for this. Oh my God. When I think of where I'm going to get alpha, I don't want to trade in the open market. I want to go to these weirdo markets like that that have not been overran by high frequency trading people and crazy quants that have an IQ way higher than me. And that's where I think, this is where I think AI creativity and breadth is better than depth in the short term with like markets. But I don't know. This stuff is.
Yeah, I agree. I think it was like a week ago that I'm not sure which CEO, like he was on the stand. I think it was like some, like, I don't know, he announced something related to the company, and then he just took all the words that was in a poly market, that he should say, like, that was a positive bet that he will say, and just read them like one after the other. So it can be really weird on these markets, and I'm not sure, like, it can be that LLMs and models will give you some alpha, but I don't know. It looks crazy to me to go and to try to predict them.
Yeah, yeah, and I'll just say one other thing, like, if in the current market, I'll part of my trading strategy is I'm very bullish on America, so I do buy and hold over long term on leveraged ETFs, which is crazy. Even the Wall Street Bets folks think this is weird, right? But it basically just means, well, if the market's going to go up, I'm going to go up 3x as much, right? If currently in the last 6 months, if you had held that, you would make way more than any of these. So I will say one other thing is I'm part of the cult of don't touch your money, right? Like I'm a strong supporter of like passive ETF kind of, like your K advisor kind of advice on how to invest. But then, I would say like also invest in stuff like gold backed securities and, unconventional versions of those kind of investments to diversify it even more. And also like foreign securities. I think a lot of Americans over index too much on domestic.
And
So,
of course, this is like not any specific recommendation. Go to
yes.
people that know what they are doing and consult with them. We
Yeah.
don't know what we are doing, right? Okay, so yeah, let's go to talk about papers. What do you think about the new Nature Medicine's paper, the fragile intelligence of GPT-5 in medicine? They basically, so in short, they just took different use cases in medicines and asked ChatGPT and they show that even though it has less hallucinations, it still have a lot of different weird things, and like it doesn't really answer correct answers, and sometimes it gets wrong, and sometimes like it still hallucinate. And they recommend to be really careful if you're doing medicines and like medicines questions and asking something that related to something that you really care about in medicine.
Yeah, this is also somewhat related to there's news about GPT-5 also much limiting utilization of its models for healthcare and legal domains as of a few days ago. We also even saw Gemma, for some reason, people were using Gemma in the AI playground that Google makes mostly for developers. And some senator got, apparently, somebody prompted Gemma 3 to do some kind of defamation against a senator, and the senator found out and complained, and they removed Gemma 3. So I look at this paper from Nature, which, by the way, please stop publishing in Nature because it's not open access. And when I try to click
Yeah.
on this, it tries to charge. Like, yes, I know about the citations, but still don't. But anyway,
I'm not doing review for any kind of this journal. I
yeah.
think that's wrong. Like they don't pay anything to the reviewer and like charge a lot of money from the authors. It's wrong.
Yeah, yeah, and just pay-per-view anyway. But so I do agree with the general thesis that most people who use these systems put far too much trust into them and often don't use features like deep research, or even if they do, they often don't actually click on the hyperlinks and verify that the information that it did just regurgitate really was the correct information. And then often they don't have enough context to know even if there were correct snippets, were they, synthesized together correctly or not. The problem is a lot of doctors don't either. And indeed, if you start going on like subreddits or communities or even talking to some of the more forthcoming doctors, many of them also admit to surviving off of resources like Mayo Clinic and WebMD. And no doctor can really be a walking encyclopedia, which is sort of what we're hoping GPT-5 in medicine could be for us. What I will say is models, being able to use them with the extreme caveat of knowing anything it's saying could be wrong and you have to double check everything, I think that they're extremely valuable, and especially valuable for the many situations where doctors will disagree with themselves. And when you need to think about, given a limited budget of resources, as we Americans often have to do for our medical problems, how to approach situations. Indeed, many Americans don't take their healthcare into their own hands enough and don't consider things like traveling overseas. For example, Singapore, a country that a lot of AI people end up traveling to at one point due to the conferences, is also probably has some of the best healthcare in the world and is much cheaper than many US like non-insured private practices. But you see very few Americans end up doing that kind of medical tourism except the most heavily motivated, which tend to be the people that survive from some of those scary cancers you hear about. So I guess what I'm trying to get at is models might actually push people into these more unconventional approaches if they're at least like fine-tuned correctly. So I don't know, I'm still bullish on language models in medicine. I just think that this is a mostly kind of legal indemnity and kind of trying to not get in too much trouble, right? And the articles like this sort of motivate paternalistic policies. I don't terribly like them.
No, I agree. I think like it requires to be very careful. Right? I will not ask ChatGPT, okay, can I take these medicines like one or twice a day? This is something that it can get wrong really really bad, and I probably will search over the internet or I will ask a doctor for it. But all these, as you said, like these soft issues, right? It like there is no one clear question answer, and there's like pros and cons, and you need to take them into account, and like maybe there are several directions or paths that you can go and to combine different medicine and things like that, like to understand them and like to know that they are exist. I think this is a great tool.
Yeah, and I have medical like family members who have serious debilitating medical conditions, mostly the similar ones to many other Americans, your diabetes and cardiology and similar. And As an example, where I disagree with the current care some of my family is experiencing, because I'm like a GLP-1 maximalist. So many of those conditions, for example, are due to metabolic syndrome, as the medical community calls it, which is people eating too much and not burning their energy and all the problems associated with that. And the GLP-1s have been showing, hell, GLP-1s, right? Like Ozempic, have been showing that they have anti-addiction properties, right? So people are taking them and then they quit gambling and they quit their, other drugs that they were doing. And so when you look at the like positive impacts of stuff like that, first of all, there isn't that much information in the language model training data about this. So a lot of ultra new medicines are not in the playbook as necessarily, unless they come up during the searches in an agentic flow for one of these models. But another is, a lot of mainstream doctors, honestly, like culture, people literally look at GLP-1s as like, oh, that's the easy button. And they think that it's socially wrong in a sense because you're supposed to suffer to lose weight. And I see a lot of doctors who are, ignoring the fact that these GLP-1s have been taken heavily for, around 20 years now and still parrot their own nonsense. Or even, there's serious contentious stuff in the medical ethics. So what I'm trying to say is, just because this, like a language model tells you something very different from your own doctor, doesn't mean it's wrong. There's real disagreements amongst people who both have like 30 years medical PhDs who have themselves each saved 500 lives, and then they'll disagree vehemently on things as basic. I know one classic one: medical associations disagree on the value, and I know it's kind of gross, but digital rectal exams. I forget, some argue that the negative effects of doing it, especially to the basically old people who you do it on, outweigh the positives of finding what are usually benign cancers, right? And so that's something where like Americans and Europeans recommend totally different things, and that's at like a country or national board level of disagreement, right? So it's worse than law in some ways.
Yeah, and I think like the solution should be at the end. The solution should be through education, right? Like we need to understand how to teach people to use these tools and what we can learn from them and how can we use them, right? Like we need to say to people, like to teach them, right? Like on these and these topics, you probably should rely on the model, but on these and these topics, probably he's wrong. Like, don't do it. Go to your doctor or things like that. And I think to just to say no, don't use LLMs at all. Don't use models. Go to your doctor every time that you think about it, and it's wrong. I think this is something that for a lot of people it's very useful, and we should understand how to use it.
Yeah, I as much as I could talk all day about this medical stuff, because we could go way off AI topic, but I'd love to just move on in the interest of,
Yeah,
to the,
let's
yeah.
Yeah, let's talk about a very interesting paper that just came out. It's called Continuous Autoregressive Language Models. And the idea it's from a group of researchers from Tencent AI Lab. I think this is how they call it. Anyway, so the idea is like every single LLM, right, that you are using, Claude, ChatGPT, whatever, right? They can just they have the same problem. They can predict only, or they predict the text only token by token, right? They have like, you have only this tiny amount of information that you can use or like you can predict. And this paper asks the question, maybe we can change it. What if we didn't predict tokens? Okay, and we use more information for prediction. So instead of predicting the next token, we will predict the next chunk of tokens. And not only that, we will predict the next chunk of tokens in a vector representation. And then we can get much more information compared to the regular tokens. Okay. And so the problem is the problem is very let's say fundamental problem in the whole field, and the way that they try to solve it is, so they basically they used, first they trained an encoder decoder model. Okay, the idea is that you have like, you want to find a way to shift from tokens to a continuous representation. So you train an encoder-decoder model that can compress the tokens and then decompress them. Okay, so you have the encoder, you train an encoder, you train a decoder to reconstruct these tokens, and now you can use it. And now they took and this is, so they train it, and the second phase of their training procedure is to train a transformer. Okay, and this is like, they call it like energy based transformer, and they took the tokens, they train the transformer, they shift these tokens to a transformer. They feed they train some projection to feed to this transformer, and then they use the hidden state of the transformer. They use it as, let's say, a random variable, okay, in order to generate continuous representation. So you are taking these tokens, you transfer them to some continuous representation with the transformer, and then you are taking some decoder, energy decoder they call it, in order to make the chunk tokens, the continuous versions of the chunk tokens, and you train it end to end. Okay, this is the idea. And I think this is very cool. I think it can get you much more information than only a single bit of tokens. Of course, there are a lot of problems. How to do it in efficient way? Can you scale it up? All the regular problems that we all know.
Yeah, yeah. And this paper is quite exciting in that I've seen many, clients that have wanted consulting assistance basically looking at this paper and asking, is this the real deal? Is this like DeepSeek was? And similarly, I saw people also asking about Project Aegeon. I don't know how to pronounce it, but that project from Alibaba about much more efficient LLM inference on hardware. And now people are looking at this calm architecture and hoping that they have something much faster to train, much more efficient to do inference on. I noticed a few things. I read this paper quite closely, actually. And unfortunately, my eyes tend to glaze over the really juicy parts, like the discussion of like energy-based models and the real training stuff. Honestly, the parts that Ravid talked about going through the core mechanism of what the architecture is and how it differs was often stuff that I'm like, okay, well, that's for the people that work on architectures. But they have some really interesting discussions in the nitty gritties. One of them is on the Breer score and why they moved to this, which is for binary events is equivalent to traditional root mean squared error, but is different for multi-category predictions like log prob predictions for being in that it's a strictly proper scoring rule. And they go and explain why, what that term strictly proper means about like, if an expected score is minimized when the forecasted distribution matches a distribution of the observation, basically. But traditionally, model scoring rules don't always follow this property. And they talk about how the kind of problems that they have when you don't follow that property during training. They also have even more interesting part of it to me as a sampling person, right? They have to completely redo the entire notion of LLM sampling for this kind of architecture, and in particular, temperature, which they consider to be the most important, has to be rewritten and rethought of from the ground up. And I would say a solid third of the paper is just them talking about this and why an exact formulation of implementing temperature requires them to like rerun inference potentially very large number of times. And so they devise this like approximation algorithm to give them like a reasonable performance trade-off as they increase temperature. But basically with language models today, your model doesn't run slower as you force it to be more coherent, but also unhinged by increasing temperature. You de facto have to run it more times to get more, a valuable continuation. But with our min-p sampling and fancy sampling algorithms, we've kind of dealt with that problem. But now for this new class of models, they don't have top P or top K or any of that stuff formulated for it yet. So if you want to raise your temperature up, good luck with 1/10 or 1/100th the performance, because it has to regenerate like 100 times. Like it's I just find it to be the opposite of elegant for how it handles being creative and diverse, which is the core fundamental trade-off problem that makes me dislike this, in spite of all the cool stuff they're doing with like energy-based models, all this discussion of Fourier score. This is a cool paper for sure. And it might even be the start or another kind of offshoot in a slightly different direction from like what a meteor is, who we talked about earlier, and getting away from the base transformer. But it's also I don't know if people are ready for these trade-offs yet.
Yeah, I agree. So for me, like the most important parts in this paper are like two things. One is the continuous, right? That like you don't need to restrict yourself to log likelihood anymore, right? Like you don't need to do these soft marks with all the problems, right? That like you can scale it. Like the like you need to be careful because like all the low probabilities things are really messed up and all these things. You have a continuous vector, right? This is so much better at the end. If we can learn, you can we can it can contain so much information, much better than probabilities. So I think this is very good if we can go to this direction. And the second thing is energy-based models. Energy-based models, I strongly believe that they can be amazing. Like they are much better than I don't know anything else, anything like all the maximum likelihood or diffusion process model that we are using. They actually in the paper they compare it to diffusion models and they got much better results. And this is not surprising. At the end, energy-based models, and here, so if you didn't read the paper, so here they use like energy-based generative heads. Okay, so as I said, you are taking the states of the transformer, you are taking some random variable, some noise if you want, you project them together to the same space, and then you are using this in order to optimize an energy function, okay, to find like the best place in your energy function. Now, the reason that energy-based models are so good is because, again, they are not restrict to anything like probabilities. You don't need to normalize them. You don't need all the overhead that we are using today in order to get normalized functions. So I believe that we can get a lot of much better results in this direction, but we need to be careful. Okay, we need to be careful because in energy-based models, and also when you talk about continuous predictions, like continuous vectors, as they are doing here, it's not clear what is the right answer. Okay, it's not clear that like your loss function will go smoothly and nicely, and everything will be nice as we see in log likelihood training models. Okay, so we need to be careful. We need to put good regularizers, and here they also use like a good regularizer, KL regularizers. So it's a trade-off, and we need to understand how to play with this trade-off. But I think it will worth it.
Yeah, yeah, and I hope I'm not misremembering this. I think they use Dropout as well, which is kind of a bringing it back from the dead kind of thing as a little bit of regularization. I hope I'm not hallucinating that.
Yeah, yeah.
Vaguely
So they
remember
use
that in.
Yeah, they use a lot of small tricks because they have a lot of MLP networks to project. Basically, they want both in their encoder decoder paradigm, so they have MLP to compress, and also in the projection of the transformer of like the tokens to the transformer, they have a lot of like old simple networks architecture, so you need to use all these tricks. And again, this is probably why like it's not clear if you can actually scale it up. Like if you need to do all the time these tricks, the big advantage of transformer or LLM is that the number of tricks that you need to do is not a lot, right? Like it scale up really nicely. You don't need for each amount of parameters you need to think about the tricks again and again. No, you are doing something and then you can scale it up, and it works almost the same, right? The problem is this model that it's not like that, and we need to think about the regularization and the tricks to balance them every. So it's a problem.
Yeah. Yeah. Cool. I don't know if you have anything else. I think I've covered all the important bits of this paper. I think it's yeah, yeah. I see we have the small training playbook listed again. I think we talked about it yesterday, but I think we just think it's so important to go over again for a bit.
Yeah, yeah. I just so we just briefly mentioned it, right? Like in one sentence a few days ago. But I think Joe, I reread it actually, and it's really really good. If you ask me, I think like if you're a LLM researcher outside of the big three companies, you probably want to read it. You want to read it because it's amazing. They started with how to choose your training framework, right? Like what are good evil metrics, and all these things, like how you are doing like de-risking, right? You have a problem, what are the trade-offs that you actually need to take into account, right? And then they go over the different attention mechanism, right? The GQA, MQA, MLA, all these things, right? Masking, the and all the SWA, like all these things, and they are going over them. They show you the trade-off. They show you like how they behave when you change things. Mixture of experts, hybrid models, tokenization, tokenizers, like what the effect of different tokenizers, and of course optimizers, right? Moon versus Adam. Adam W, the parameters, hyperparameters tuning affected, and then they go over data, okay, like how scaling laws behave, um, what do you like, how you mix data sets, for example. This is something that you will not find something like that anywhere, almost, right? This is very fundamental problem that you need to solve if you want to train a model. So yeah, like curriculum learning and what is the effect of the samples order and things like that. And then I think this is very cool results section they actually show. It's what get wrong, like what where things may not go as you planned. Okay, so like how you debug your model, and what is like now when something like the loss just like I don't just spike and then everything break up, what you need to do, what is happening in scale, and like how to like if you have bug there, and like how you're I don't know how you try to deal with that. So this is very important. And then after they are doing, of course, post training, like how you set up the SFT baseline and when to do RL, how you do a GPRO to make it smarter on math or your specific problem. And then they are talking also about infrastructure and GPUs, GPU fundamentals, right? Like the communication pattern, parallelism strategies, um, how to debug NCCL errors, and cluster bottlenecks. All these things, all these are like the whole pipeline, right? That if you read a regular paper, you will not find it. So one way is actually to do it and to try to do it again and again in different scales and to try to solve it by yourself. And another solution is to read their if it's much shorter and will cost you less GPUs hours.
Yeah. Yeah, I agree with you about it every bit. I'm glad you at the very end talk about the data center and hardware stuff because even if you've got all the theory skills, ultra high IQ could figure out all these things. The data center hardware stuff that just costs so much money to even be put in front of the computer to make all the mistakes you need to make in order to understand things and really going into the depths of the various types of parallelism and the trade-offs. I mean, you'll also see how Hugging Face will think, as a company thinks about things based on the vendors that they have, right? They're a very GPU poor company given their valuations and how they kind of handle this. I'll point out, I tend to think that we're deep on the path of the cyberpunkification of society. And, with AI being winner take most, that I don't think that documents that are effectively how to go from zero to hero like this. I mean, the equivalent is this would if you thought of the equivalent for this with like nuclear, this would be like how to make a nuke, basically, right? Like how to make your own LLM if you've got the compute, basically. And so I interpret documents like this as nation state levels of importance because I guarantee you almost nobody except the big four labs in America right now, Grok, Gemini, Anthropic, and OpenAI, and then the labs in China, and then Hugging Face and Mistral in Europe, and maybe a handful of others. I guarantee you nobody else has that kind of knowledge, and certainly not put together that cleanly, especially with all those interactive demos. Part of why we love this is that this was made with so much love by humans, right? Like demos, like little things in there. It's like, oh, you need to calculate something important for like how much memory your model's going to need for, it'll have a little app built into that kind of training playbook. So yeah, yeah, everything to what you said, Ravid.
Yeah, yeah. No, but and I think like I wish more companies will do it. It's really like even when labs, right? Like university labs are publishing papers. I think they should do it. They should say what was okay, what got wrong, like what are the different aspects and considerations that they took into account, right? All these things is very fundamental at the end. And I, yeah, I think they should do it much better than current papers are doing.
Yeah. Yeah. So yeah, I see this Twitter post here, complaining about how everyone is doing benchmarks these days. I'll just quickly start by saying I remember 3 or 4 years ago, people were complaining there weren't any data sets or there weren't any good benchmarks. So wow, the tables have turned, and I do not complain about this. I think the one complaint is that papers expect people to always have a data set or benchmark now, which I think is a high expectation.
Yeah, I think like my main, let's say, argument here or complaint is that it's not clear. LLMs or like models in general today are really good in fitting data sets. You present a data set, probably after 2 months, all the models will get very good results on it. And it's not clear if this is a good direction. These data sets, some of these benchmarks are really specific, and it's not clear if getting better on these benchmarks are give you something, right? Are making models better in the direction, whatever it will be, um, that we want to go, right? So I think we first need to ask what are the tasks and the problem that we actually care about, and not just generate datasets after datasets, benchmark after benchmark, in order to feed them and to make to reach some saturation um, on these problems.
Yeah, yeah. I think it's also just, because so much of a focus has come on these benchmarks and evaluations, most of them are really small. I've been, lucky that the few that I've released personally have been very large, but that's also because of the nature of the task I've worked on. And so I'm able to say on my papers, oh, hundreds of thousands or millions of records and super deep and all these kind of things. But I think most researchers don't have the luck of being experts in an esoteric domain that AI researchers haven't looked at before, like debate evidence in my case, right? So I think most people don't have a good source and often have to there's a lot of like LLM created data sets and benchmarks as well, which the better of them are often using structured generation to create those. A lot of stuff in like persona generation looks like that. And you know, in terms of LLMs being really good human approximations, even for like judges, right? LLM as judge is also a big deal at the same time. I think that's everybody's got to get their PhD, like we need to get people their paper and their citation. So I don't think it's that bad. I think the field could be doing a bunch of other worse things for this, such as everybody deciding to use AI to write position papers all at once and spamming archives. So I think this is not worth critique.
Yeah, yeah, I agree, but I still think that methods or like papers that actually want to generate or develop new methods are very important. Let's say it like that.
That's true.
Yeah, yeah. I have one more paper that I wanted to talk about that I found it really cool. So it's called cartridge. The same as video, the video thing, right? So the video extension memory, basically. So it's called Cartridges, lightweight and general purpose long context representations by self-study from a Stanford group. So here's the problem. So models now have billion token context windows, but they actually using them uh, is really expensive, right? And it can be really, really slow. And this is why we are using a KV cache, right? And so quick reminder, KV cache in transformers. So KV cache stores the key and the values vectors from the attention for the already processed tokens, right? And so without it, like you recompute everything for each new token. So it will cost you n to the square. But with this cache, you just compute it one and reuse it. So it will cost you n. Okay. So it's scale linearly. But for long context, it's really a lot. Even linearly, it's not good enough, right? So yeah, so they try to solve this problem of the KV cache, and they try. The solution is very simple. Let's compress it, okay? And they ask the way that they are doing it is they say, okay, what if we spend way more compute at the beginning, okay, in the training to create a much smaller cache, okay? Now, of course, it only makes sense, for example, when you have multiple users query the same document, okay, shared code base, some patient record or whatever. And you can train offline. The compute is cheap when you train offline. Now, the idea, the mechanism is simple. It's kind of like prefix tuning. Okay, you freeze the LLM, you initialize a small trainable, more compressed KV cache. So let's say that you have like 1,000 tokens instead of 128,000, and you backpropagate the loss directly into this KV cache, key and value vectors, okay? And you end up with a compressed representation that you can swap in and out like the video game memory storage. Okay, so but what is the problem here? If you just train it natively on the raw text, you will overfit. You will memorize everything, okay, and you will memorize the document perfectly, but you can't do anything else. You can't generalize to any other text. You can answer any other questions, basically. And so what they have done, they call it self-study, and they train on synthetic conversations about the document. They create two agents that they make this synthetic data set, basically that you take an agent and feed the context to this agent and ask him to generate questions and answers for this. So you generate synthetic data. Now you have a lot of questions and answers for this document, for example. And then what they have done, they did the context distillation. Okay, so for each question, you have the teacher that has the full context and the question, and you get the probability distribution for it. And you have the student with the small KV, and you try to distill the student to match the teacher. You minimize the KL between them, and you backpropagate the updates. You updates the KV, the small KV cache that you are trying to train, and then you so basically your small KV cache learns to mimic to produce the same answers as the full context model, and it doing it based on the compressed representation, and you're doing it on multiple scenarios and diverse conversations and etc. etc. And the results are really good. They did some medical QA and things like that. They are much more efficient. You can compress by, I don't know, 2000x, things like that, like huge compression, and to get the same results. Yeah, you want to say What
Yeah,
you
and we only have a few more minutes because I do actually have to drop in just a few. But I'm really excited about this paper for a few reasons. One, I mean, there's all the inference time optimization stuff they talk about. But being able to massively improve the effective context window through these techniques to get it from, they quote, that I use that 1/10th rule of thumb roughly, and that's about what they estimate is correct, about 100,000 tokens on a 1 million context window as the effective context length. They get it as high as nearly, I think it was 480,000 around there. So almost to half of the theoretical context window before the model starts becoming incoherent. They also show that you can compose KV contexts or KV caches together, which nobody expected this and thought you'd have to do some retraining, which means that you can effectively you could compress a far larger number of documents and have the model treat them all in context and answer questions about both of them than normal. I think that's how that works. I'm not exactly sure, but if and I interpret composition to mean that, and that it means that it's kind of like a low rank adapter now, right? Where I could have like 5 of them applied, right? And that's what they talk about. I think they used 6 at a time on some of their experiments, if I read this right. So this is a very neat paper, and I hope that we get models where I can eventually one day use every single token in your context window and not feel like I'm going to get gibberish.
Yeah, yeah, I agree. And you can take it also for personalization, for example, and then a lot of different problems, like to train small KV cache for different aspects, for different scenarios, for different personas, whatever. I find it very, really great paper. Okay, anything else that you want to add?
No, it's a great episode. And I love being able to kind of just talk about the news, right? And now for our next episode when we interview some of the great minds that we have, we'll keep them all on their research.
Yeah. Yeah, so okay, so this is like, let's say, experimental format. Let us know what you think about it and what you prefer and what are the good and bad things that we have done. We really like to hear your feedback, and till the next time. Thank you so much.
Yeah, have a great rest of your day.
Thank you. Bye bye.